So now we can really do some work on the computer and pass it over to the CB2 pretty easily. And that's going to be a lot more convenient than trying to type it in the editor, which wasn't bad, but it was just limiting.
So one last thing about the serial communication with the CB2, and then after this one, we're done. Sending programs from the computer at 2400 baud, it's kind of slow. I mean, it takes a while to send all 100 lines of a BASIC program. So I thought it would be great to take advantage of the other feature that the CB2 has, which is it has another communication port. If you look very closely in the PCB, you'll see there is an RX1 and TX1, but also an RX2 and TX2. And that's why we have those different numbers in the speed menu. When we switch from 1200 to 2400, it says 1, so that refers to it's going to be using port 1. And then when it switches to 9600, it's port 2. It turns out I had this USB to serial interface as well. And this one looks like it's a UART one. So we could connect this directly to port 2. Let's give that a try. It actually has a 5-volt connector, so we could power the CB2 directly from it. We start by connecting the transmit and serial lines to the second port, and we need to cross those over, so the receive from the serial interface goes to the transmit of the CB2 and vice versa, and then we connect the power and ground. And now we power everything with a USB cable and connect it to the computer, and we're ready to go. On the CB2 side, we need to set the speed to 9600 baud, and then we need to change the serial in-out from simple, which means RS-232, to standard, which means it's accepting UART-like voltages. Okay, as a first test, I'm going to send this program over to the computer, and yeah, that was really quick. We got the full listing on the PC. And now I'm going to try it the other way around. I'm going to send a different listing to take over this slot on the CB2. So yes, and need to paste it on the terminal. And there we go. Although this is really slow. Yeah, this is very slow. This is not 9600 baud. That's very weird. We need to look a little bit more into this. All right, so let's see what exactly is happening with the transmission line. So the interesting thing is that it was getting the characters, but it was just getting very slow. So we're going to start this again. Transmit, yes. Let's look at the... Oh. All right, that's very interesting. This is an individual character being transmitted, and that's the speed that we expect from 9600 baud based on what we saw earlier. But then there's all this delay that is just waiting in between characters. I don't know why it's waiting that long. I wonder if it has anything to do with the program itself. I mean, it could be the driver, a really bad driver for this. It could also be the terminal program. Let's try a different terminal program. Okay, I've connected TerraTerm. Hopefully this one is different, and paste. Oh, there you go. It just went right away and it sent the data really quickly. Let's see if I can catch it in the oscilloscope. Yeah, look at that. There's no delay between the characters. So it was just hyper-terminal that for whatever reason, maybe this is a setting that I can change, but for whatever reason, it was adding a pretty big delay between characters. Okay, that's great to know. Let's do one final test. Let's try sending data at the highest speed that the CB2 supports. So I'm going to switch over to 38K and let's receive a program. Yes. And wow, it detected that I sent something, but then it just says okay and it doesn't show anything. What if we send the program to TerraTerm? Send, yes. Oh, and we just get garbage on the screen. Well, it is a big jump from 9800 to 38K, so I don't know, maybe this guy doesn't support that speed. I mean, the driver does because it lets us configure it that way, but well, I think 9600 is pretty good for the amount of data that we're going to be transferring back and forth. One of my main complaints last time I looked at the CB2 was the 100-line limit on basic programs. I imagine that comes from the limitations of the ATMega microprocessor, although I don't really understand why we can't get around it with a few minor changes, so I might have to look into that in the future. But in the meanwhile, there's a way to let people create larger basic programs, and that's with the call keyword. It's very similar to go sub, to go to a subroutine, but it indicates the program slot first, and then the line number to jump into. There are a total of 8 program slots on the CB2, so that extends it quite a bit. The thing that is a bit weird is that it uses an absolute program position instead of a relative one. So if a program is designed to be in 1, 2, 3, you can put the first one anywhere you want, but then the second and the third have to be in the slots 2 and 3. But it's better than nothing. So let's give it a try. There's already a program in the CB2 website called 2048, written by Wolfgang Schmidt, that uses 3 program slots. The game is based on the original Threes game, but with powers of 2, which is a pretty common clone. It looks pretty simple on the surface, but the rules are relatively complex, so it needed more than 1 program slot. Here, for example, we can see how it calls a subroutine in a different program. So let's go ahead and load it up in the 3 slots now that we know how to communicate with the PC finally. And there you go. It's not particularly visually sophisticated, but it's great that we can get something of this level of complexity in the CB2. So this is a perfect example of what you can do by chaining multiple program slots to create a more complex basic program. So what is my wish list for the CB2? The main thing by far would be more static RAM. That would mean probably a new microcontroller and an updated firmware. That would allow you to edit larger basic programs without the limitations we have right now. And as a side effect, it would allow you to have more data during the runtime of the program, which would allow maybe for more complex basic programs. So that would be fantastic. The next thing is that the sound on the CB2 is really basic. I think it would be really fun to have an expansion that connected some kind of sound chip, maybe like an AY sound chip, to the CB2 and exposed that sound generation capabilities to the microcomputer. That might even be something that I might want to tackle in the future because it sounds like a really fun project, and it would have forced me to learn about assembly programming on the CB2, which is something you can do and we haven't talked about so far. So that's it for today. I hope you enjoyed the video. If so, please give it a thumbs up and subscribe to the channel. Until next video, see you then.